Okay, so this will be the last lesson for this semester. I know that some of you guys are really glad that you don't have to do any more math. And summer will officially be here. I guess you guys have to stick to school until Friday, and then that's it. Okay, so I'm gonna be posting this on Tuesday. On Wednesday, I'll hold my office hours, and then on Thursday, I'll give you your final quiz, which I will just make it a Google form quiz. Okay, so it will be multiple choice, and I'll probably give you one or two questions, and then that would be it. Okay, so again, thank you so much for the students who have worked really hard, who have been watching my videos. This is the final one. I kind of feel a little emotional over here because I know that you know um, it's coming to an end. So again, thank you so much for being such amazing students. Um, I think we can all agree that maybe when we were in a classroom setting, it was a lot more fun. But we have to do what we have to do over here, right? So um, under the circumstances, I think we're doing a decent job. So let's just finish this off now. So my question to you is, what happens, right? Can we work backwards and find an angle in a right angle triangle? Okay, that's a starter question. This it's a simple yes or no question, right? But let me just elaborate a little bit. Okay, so let's say if you have a right angle triangle that looks like this with a 90-degree inside, right? And let's say this side is 3, this is 4, and this is 5. Okay, my question to you is, can you calculate this angle theta if you know the sides? Okay, and the answer is yes. Okay, the answer is yes. And actually, you could even make this. You could even do better than that. Okay, you don't need all three sides to find theta. You only need two sides. Okay, if two of the three sides are given, so let's say these two, you can find your angle. Okay, by doing the opposite. So I'm gonna show you what the opposite is. So this was 4, right? It doesn't matter which two sides are given, right? If the hypotenuse is not given, not a problem. You can still calculate the angle theta. Okay. Um, and we're going to do that this class. Okay, so the answer is yes. And you only need, you will need um, either, oops, that's not how you write, either two of three, the three given sides, right? You'll either need or an extra angle. What do I mean by that? Okay, an extra angle. So let's say everyone knows that, what we're doing, hopefully by now, that it only works in a right angle triangle. So what if you knew that this angle was, let's say, 50 degrees? Okay, I'm just making it up. Okay, what if you knew that this angle was 50 degrees? Then theta would just be 30 degrees, okay? Because inside a triangle, this is from like junior high or maybe even elementary school, all the angles have to add up to give you 180, okay? So if you do 90 plus 50 plus 30, you're gonna get 180, okay? One way to find this 30 is to just do 180 minus 90 and then minus 50, and then you will, or 180 minus 90 plus 50, right? So 90 plus 50 is 140. And then if you, not 30, this should be 40 degrees actually, okay? Because, yeah, 40 degrees. So 90 plus 50 will be 140, and then 180 minus 140 will equals to 40 degrees, okay? So that's how you find that angle, okay? So those are the two ways. But now let's build on that, okay? So practice question. This is, again, a simple one because all three sides are given. When all three sides are given to you, it becomes very easy because you can use SOHCAHTOA, you can use any of the three ratios. Okay, so before we continue, first step is to identify which angle are we looking for. Okay, so let's just focus on this angle for this question. Okay, and then I'll find the other one in purple if you want um, afterwards. Okay, um, so if I'm looking for the angle theta, let me figure out now. So I'm looking for this angle, right? Theta. Now, from this angle's perspective, the opposite side will be this one, My hypotenuse, remember, is always opposite to the 90-degree angle. So if this is your 90-degree angle, the side opposite to that is this one, right? So this is your hypotenuse. And then, the remaining side is your adjacent side. Okay, so now you have OA and H. And let's write down SOHCAHTOA, okay? And I'll show you a few things that you will like. Okay, SOHCAHTOA. Because all three sides are given, you could use any of the three ratios, okay? I'm going to use, again, I'm going to use, let's say, sine. Okay, so sine of my angle, right, is equals to the opposite side divided by um, the hypotenuse, okay, h. Okay, now, do I know what my angle is? I do not know what the angle is. So theta will remain theta, but I know what my opposite side is. It's actually 5, and my adjacent side is 13, okay? Now you see sine theta is equals to 15. I'm interested in solving for theta, okay? Um, it's not sine times theta, okay? These guys, they go together, okay? So you cannot divide by sine on both sides or do anything crazy like that. Here is what you'll have to use something, remember when you do algebra, you always have to do the opposite, okay? So now the question is, what is the opposite of sine, okay? The inverse of sine is something called sine inverse, okay? And again, you have to do that to both sides. Okay, so basically, let me make some room. At this stage, what you have to do is 5 over 13. Take the inverse sign, sine inverse. So you have to put sine, put a like a -1, which looks like an exponent, but it's not really an exponent of this. And then you take sine inverse of the stuff on the right hand side, because remember, whatever you do on the left hand side, you have to do the same thing on the right hand side. Okay, so the sine inverse and sine will cancel each other out, which will leave you with theta, and theta will just equals to sine inverse of 5 divided by 13. Okay, now from this step, you guys can directly go to this step. Okay, you don't have to I guess take the sine inverse on both sides, okay, like I did over here. You can directly go from here to there, but I just wanted to show you how algebra works, right? It's the same way, it's the same thing all the time. You have to take the inverse and you have to do that on both sides, okay, which is what I've done. The sine inverse and sine will cancel each other out. Now it's just a question of what is this value, okay? What is this value? What is sine inverse of 5 divided by 13? And how do you find it? Okay, so go back to your calculator. You're going to have to use the second button or the shift button and then click on the sine option, right, in your calculator. So click on sine. It will give you sine inverse, and then just do 5 divided by 13. Okay, close the bracket, enter, and you're getting 20. Let's just stick to one decimal place. Okay, 22.6. Okay, so this angle happens to be 22.6 degrees. Okay, this one over here. Actually, let me just be consistent with my colors. So I'm gonna change this guy to purple. So let me erase this. Okay, this angle over here, this theta is 22.6 degrees. Now, what about the theta in green? Okay, how do you find the theta in green? Simple, right? You know that this is 90 degrees. This is 22.6. So you can just add the two angles up and subtract it from 180. Okay, so I'm just gonna call this theta 2. Okay, just to distinguish the two theta. So this is theta 1. I know the color already does that, but when you do math, right, you do that with a pencil, and it's all done in black. So that's why you have to distinguish that using numbers. So theta 2, right? If you were to find theta 2, let me just add an extra page. Um, so theta 2, and let me be consistent with my colors. Theta 2 will just equals to 180 minus 90 plus 22.6, okay? Which is 180 minus, so it's 67.4 degrees. Okay, so that's how you would find theta 2. You could also use your trig ratios to find theta 2. Okay, that's another way of doing it. Also, I want to show you, I used sine to find my angle, but you could have used any ratio. Okay, so let's just draw the triangle again over here. I want to emphasize this point because it's important, right? So this was 12. Triangle kind of looked like this. This was 12, this was 13, and this was what was it, 5? Okay, and this was the angle that I calculated, theta, using my sine ratio, right? So now why don't we use tan? So tan is, so again, using SOHCAHTOA, right? So you could use cos, but why don't I use tan? Okay, so the tan ratio is tan theta is equals to, again, this is my 90-degree angle, right? So maybe I can do that in green. So this is your 90-degree angle. So again, this was your hypotenuse, right? This is the side opposite to your angle. So this is O, and this would be your adjacent side, okay? And let me make the 5 look a little nicer. Okay, so tan is equals to the opposite side, right? Toa, right? Opposite, and then divided by the adjacent side. I don't know what my angle is, so I'm just gonna leave it like that. My opposite side is 5. My adjacent side is 12. So the angle will just equals to tan inverse, right? I'm just skipping a step over here of 5 over 12, and this will also give you 22.6. Okay, so why don't we do that? So tan inverse, it doesn't matter which ratio you use. So tan, so shift, click on tan, and then 5 divide by 12, and then enter. That also gives you 22.6, as you can see, right? So 22.6 degrees as well. So in other words, what I'm trying to show you is that because all three sides are given to you in this picture, okay, all three sides are given. You know that this is 12, this is 5, this is 13. All three sides are given. You can use any ratio, okay? Even cos will give you 22.6, okay? Just pick your favorite one, and you're gonna get the same answer, okay? So I use sine and tan. If you would like to practice more, you can even use cos. Just do adjacent over hypotenuse, take the cos inverse of that, and you will see that your answer will be 22.6, okay? Now you see the question becomes more difficult when only two sides are given to you in a triangle, okay? So now this question is asking you to determine angle G. So angle G is this one, and H, okay? So let's start off by first finding angle G. Angle H is simple because you can just do 180 minus that, or you could, it doesn't matter which one you find first. You can find H first if you wanted to, okay? But because they're asking me to for angle G first, I'm just gonna, again, the SOHCAHTOA thing, right, will only work if two of the three sides are given to you, okay? If they are, then you can easily find this angle. But now that because only two sides are given, not three, only one of the ratios will help you find the angle. So why don't we write down SOHCAHTOA and see which one will help me. Okay, so first, I guess, label everything in a triangle, right? This is my 90-degree angle, so the side opposite to that is your hypotenuse. So this is your hypotenuse. Oops. And this is the angle that you're interested in. Let's just call this theta. So the side opposite to that is your opposite side, and this is your adjacent side. Okay, so what do we know? We know that we know the hypotenuse is given to us and the adjacent side is given to us, okay? So in this case, I'm gonna have to use cos. Only cos will work because remember, you can only have one unknown. Your unknown in this case is the angle itself. Cos is the only ratio which can work because both your adjacent side and your hypotenuse are given based on the picture that you have. Okay, so using this picture, I'm gonna solve for my angle. So I know that cos theta is just equals to adjacent side over the hypotenuse. I don't know what my angle is, so I'm gonna leave it like that. Adjacent side is 6, hypotenuse is 14. So the angle will just be the cos inverse of 16 divided by 14, okay, which will roughly equals to, they're saying to the nearest tenth of a degree. So again, a number after the decimal point. Okay, so let's take the cos inverse, shift cos inverse, and what was it? I forgot the number. Sorry. 6 divided by 14. 6 divided by 14. Close the brackets. Enter. 64.6. Okay. 64.6 degrees, if I'm rounding this up correctly. Yes, I am. Okay, 64.6. Now, to find the third angle, again, very simple. The angle in green, you can just do 180 minus 90 plus 64.6, just like I did up there. But I'm actually going to show you another way of doing it. Okay, so the other way that you could do is just use SOHCAHTOA again, right? So now I'm looking at this triangle from this angle's perspective. Okay, so in green, my hypotenuse will always be this one. Okay, this is my hypotenuse no matter what angle I'm looking from, right? No matter which perspective I'm looking at this triangle from, but my opposite and adjacent sides will change. Look, because if I'm looking from this angle's perspective, then the opposite side is actually this one. So I'm gonna do this in green to distinguish that, right? And because this is the opposite side, my hypotenuse is still the same. This will now be my adjacent side. Okay, so again, if you're changing your angle, then your adjacent and opposite sides will change. Okay, it's just a question of a perspective in this case. Okay, so one way to find the angle is just to do 180 minus the sum of the two angles that you've calculated. The other way would be to use SOHCAHTOA again. So why don't we do that? Because if I use SOHCAHTOA again, um, now this time in green. Okay, so let's just clean this up a little bit. In green, what do I know? I know my opposite side, right? I know my opposite side, it's 6, and I know my hypotenuse is 14. So I have my opposite side, I have my hypotenuse. So if I'm looking for the angle in green, I will have to use the sine ratio. Okay, so sine of my angle is equals to the opposite side, which is 6, right, given from here, divide by my hypotenuse, 14. So I can just easily solve for theta, right? Theta will just equals to sine inverse. Okay, it's not sine exponent -1. Even though it looks like that, it's not that. It's called sine inverse, okay, or arc sine. But let's just stick with sine inverse. 6 divided by 14, and then this will approximately equal to 6 divided sine. Oh, okay. Let me just use the calculator in here. So sine inverse, right? 6 divided by 14, and then enter. 25.4. 25.4 degrees. Okay. And just to validate that this is the right answer, why don't we check if we why don't we use this angle here in purple, and do 180 minus all that. So let me just clean this up. So I know that this angle here in purple is 64.6, right? So if I'm looking for the angle in green, I could also calculate the angle in green using this formula, right? 180 minus 90 plus 64.6. Okay, so this is a plus, right? I'm adding the two angles up. And if you work this out, right, then this is just 180 minus 90 plus 64.6, and that gives me 25.4 degrees as well. Okay, so as you can see, two ways of doing it. You guys choose whichever method you want. I would honestly do this because it's just or I mean, honestly, this might be even faster. I don't know. It's a question of preference. Both of them will take equally as long. But I think you should know how to do this, right? Because you should know that the angle inside a triangle always adds up to 180. So if two of the angles are given to you, then you can easily calculate the third one by subtracting, you know, 180 from the two given angles that you have, okay? So just to practice, I'm going to ask you to do this question, okay? Here are the solutions. Angle K is 22. Angle M is 68. So work this out. See if you are following along, okay? But I'm going to move on. So you can pause the video here, try this question. Please do that. I think, this might be, I think the inverse, right? I think this step over here might be confusing some of you, right? But it's just to get data, you need to take the inverse on both sides, kind of like what I showed you on the previous page. And this is how you do it, okay? So now let's go on to the next question. Okay, this is what your quiz will look like. I'm gonna ask you to solve a triangle. So it says solve this triangle. So what that means is when I'm asking you to solve a triangle, that means I want you to tell me all the side lengths. So this one, I need to know what this side length is, what this side length is, as well as the angles. Okay, I need to know all my angles. Okay, so side lengths and angles, everything. Okay, so basically I need all three angles and all three sides. Currently I'm missing one angle, so why don't we find the angle? The angle is the easiest um, you know um, I guess thing to find, because two of the angles are given to me. So let's just call this angle theta. Theta, and let me write this a little small so that I have enough space. So theta will just equals to 180 minus, because two angles are given, 90 plus 25, right? And then it's just 90 plus 25. So if you want, this is just 180 minus 115, which is just equals to 65 degrees. Okay, so I have all my three angles, but I only have one side. Okay, I only have one side, and it's this one. So why don't we use SOHCAHTOA, okay, um, and figure out what the other two sides are. Again, it's your choice. You can either use this angle, the 25, or the 65, the new angle that I have. It doesn't really matter. Okay, I'm gonna just stick with the 25 because that's how some of you might choose to do the question, because some of you might choose to do this step at the very end. So you might just start working with the 25 to figure out what the other sides are. So that's what I'm going to do. So let's focus on this angle over here in purple. I know that this is the opposite side because it's the opposite side, right? Because it has to be opposite to the angle. The side opposite to my 90-degree angle is the hypotenuse. So this has to be the adjacent side, right? Now that you have everything, let's see which ratio would work best. Okay, so ka or toa. Okay, so I have my opposite side, and so I could use sine opposite side. Okay, I have the angle, so I have, I know what sine of the angle is. I know what tan is. Okay, so I could either use sine, because sine will help me find the hypotenuse, and then once I find the hypotenuse, I can use tan to find my adjacent side. Okay, so those are the two ratios that I will use. Or what you could do is you could find the adjacent side, or the hypotenuse, doesn't matter which one you find, and then use the Pythagorean theorem. Okay, don't forget about the Pythagorean theorem. Still applies because we have a right angle triangle. Okay, I'm not going to do the Pythagorean theorem because it's actually, I think, takes more time. Okay, so why don't we start with let's just start with sine. Okay, um so sine of my angle, sine theta is just equals to opposite over hypotenuse, right? I know what my angle is. It's 25. My opposite side is this one, 5. I don't know what my hypotenuse is, so I'm just going to leave it as h, okay? So this is kind of tricky, right? How do you solve for h? Again, there's many ways of doing it. One way would be to, the h is in your denominator. The easiest way would be to understand that sine 25 has denominator 1, right? And then you can just cross multiply. Or if this is confusing you, then why don't we just multiply by h on both sides, multiply by h, so this will disappear. Now you have your h on top. Okay, so you have sine h times sine of 25 is equals to 5. Now because you want h to be all by itself, you're gonna have to divide by sine of 25 and then divide this by sine of 25. Okay, sine of 25, and then this will cancel. Remember, the sine and the angle go together. You cannot, um, like you cannot get rid of the sine and just leave the 25, or get rid of the 25 and leave the sine by itself. They have to go together unless you take the inverse sine. Okay, so in this case, I don't have to take the inverse sine because I'm not solving for the angle. I'm only solving for h. Okay, because which is my unknown. So h will just equals to, use your calculator, do 5 divided by sine of 25. Okay, so 5 divide by sine of 25, and that gives me 11.83. Okay, 11.83. And again, make sure that your units are matching. And for my angle in this question, yeah, make sure you're putting degrees. Okay, make sure you're putting your units, super important. 18.83. Now let's use tan to figure out, so I'm gonna use 10 to figure out the adjacent side. Again, now that you have two sides, you have your h and you have this side, you can actually use the Pythagorean theorem, but I'm not gonna do that because it will be slightly longer, but you could do that. Okay, so tan of your angle is equals to the opposite side, right? Divide by the adjacent side. So tan, I know what my angle is, it's 25. My opposite side is 5. My adjacent side is unknown, so I'm just going to leave it like that. Okay, now this one I'm going to do this by cross multiplying. Okay, so my denominator is 1, just to show you a different style. So you multiply these two numbers together. So 5 times 1 is just 5. And then tan of 25 times a is just, tan of 25 times a, right? You cannot combine them together, times a. And then to solve for a, you have to divide by tan of 25. And then you have to divide by tan of 25, okay? So this will disappear and a will just equals 2. Again, it's an approximation, so maybe I should put an approximation symbol. It's not exactly 11.3. A will equals to 5 divided by tan of 25. 5 divided by tan of 25 is equals to 10.72. 10.72, yeah. So it kind of makes sense, right? To the nearest tenth, they're telling me, right? So why don't I remove this 3 and my, it's 10.7, right? Okay. So 10.7, please read the question carefully, right? Because they will specify how to round up your numbers. So 10.7 was it? Let me, just getting confused here. 10.7, okay. 10.7 centimeters. Okay, so now you have all three sides. Okay, you know that your adjacent side is 10.7 and your hypotenuse is again, it's roughly, right? And this one is roughly 11.8. And it kind of makes sense, right? Hypotenuse is supposed to be the longest side. Now, one way to check if you have the right answer is to just use the Pythagorean theorem. Take, do 5 squared plus 10.7 squared, and then take the square root of that and see if it gives you 11.8, right? So basically, using the Pythagorean theorem, I know that a squared plus b squared should equals to c squared, right? So, so basically, if I, so yeah, you can kind of like check your work using the Pythagorean theorem. One way to do that is to just do it this way. Okay, so if you take the square root of this, take the square root of that, that tells you that a squared plus b squared square root is should give you c. Okay, so if we do 5 squared plus 10.7 squared, so let's take the square root. How do you take the square root? I think shift this one. Square root of what was it? 5 and 10.7. Okay, so 5, I'm just checking, squared plus 10.7 squared, just to see if it gives me a number close to 11.81, and this is 11.8. See, so it does work, right? So you can kind of like at the end verify if just by using the Pythagorean. This is an additional step, you don't have to do this, but if you do this, you will know that you have the right answer, right? So you can kind of like just square this and square that, and then add them up, take the square root, right? And then see if it actually gives you c. Okay, so using this. Okay, so that's a nice way to verify, because again, remember, we're working with a right angle triangle. So even though we're doing some fancy math over here, right, using SOHCAHTOA, setting up the ratios, we can still use the Pythagorean theorem. Okay, unfortunately, Pythagorean theorem is kind of like the basic version of what we're doing, because it doesn't include angles. Okay, so this is kind of like more powerful, but Pythagorean theorem still holds, okay, because it's a right angle triangle. So for homework, what I want you to do is to do the remaining questions on your worksheet. Remember last class, I think I told you to do question 9 to 16. So whatever questions are remaining, please do those ones, and especially the ones where I'm asking you to solve the triangle, okay, because this is what will be given to you on the quiz, where, right, so solve the triangle. By that I mean I want all three sides and all three angles, okay? So those questions are what you should, if you're busy, do at least those ones, then you will be ready for your quiz. If this did not make sense or anything, please send me an email. I will be holding office hours on Wednesday. And that is it. Okay, so that is it for this semester. Thank you so much for listening or for watching my videos. You guys have a nice day. Take care. Bye.